All right, so we've talked about a few DAX filter functions already, namely calculate and all. Now I want to talk about a third called filter. Now, filter by definition returns a table that represents a subset of another table as defined by some filter expression. So very simple syntax. First argument is the table that you'd like to filter. Might be a lookup, might be a data table, doesn't matter, any table. And the second piece, or the second argument, is the filter expression, a Boolean true-false filter expression to be evaluated for every single row of the referenced table. Now, a couple of very important things to call out here. Number one, filter can accommodate more complex filter expressions than a standard calculate. One great example is that you can actually integrate measures into your filter expressions within a filter function. Like this last example here, product price is greater than a measure named overall average price. And the other important thing to note is that filter is what's called an iterator function, meaning that it iterates row by row by row by row through an entire table, testing that filter expression, that true-false statement. And for every row where that expression returns true, that row is preserved. Any row where that filter expression is false, that row gets chopped out. So as a result, it's going row by row and chopping out any rows that don't meet the filter expression. And then by the time it's gone through the whole table, you end up with this subset, a smaller table containing fewer rows and only the rows that meet the filter expression. So this is different from how a calculate works. Calculate is not an iterator, meaning it doesn't actually eliminate rows from the table. It just identifies filter context and modifies it. Filter, as an iterator, is actually producing a new table as a subset of the original table based on whatever filter expression you're using. So, important point, filter is used to add new filter context, and it can handle more complex filter expressions than calculate, like we just said by referencing measures, for example. And since filter spits out an entire table, you won't use it by itself. It's almost always used as an input to other functions like calculate or sumx, just like we saw with the all function as well. So little tip here, since filter is an iterator function, it can be slow and it can be pretty processor intensive. Not a big deal at all if you're working with manageable file sizes, but as a best practice, don't use filter if a standard calculate function will get the job done. So let's open up our AdventureWorks file and practice creating a brand new measure using this filter function. All right, once you're back in your AdventureWorks report, remember that we added this overall average price column by combining calculate and all. And now using that column, I want to create some sort of measure that will calculate our total orders, but only for products that are greater than the average price. So I want to see sales for higher than average priced items. And I want to name that measure something like high ticket orders. So let's go and right click our sales table and add a new measure. And we're going to name this measure high ticket orders. And again, we're going to start by calculating our existing total orders measure. And now for the filter statement, let's step back and think about this for a minute. So to recap what we're trying to do is we're trying to return a measure that's going to capture the volume of orders, but only for high-priced products or products with a retail price greater than the overall average, which we know is $714.44. So the first thing you might be inclined to try is to say, okay, in our filter argument of our calculate, let's find that product price field. Product lookup, product price, tab that in, and say, okay, so if the product price is greater than the overall average price measure that we created, and then close the parenthesis, right? So we're calculating total orders in cases where the product price in the product lookup table is greater than the overall average. We press enter, we get an error. And the error message is not very helpful. It says a function calculate has been used in a true-false expression that is used as a table filter expression. This is not allowed. So classic Microsoft writing a very wordy, very confusing error message when they should have just said, hey, you can't use a measure in your filter argument of a calculate. That's really what's going on here. That's what it has a problem with. So if we edit this and delete the reference to our measure, our overall average price measure, what we could do if we were lazy is just type the average, right? 714.44, because this now becomes a simple filter expression, column criteria. And if I press enter, that will go through just fine. It added a measure for high ticket orders. And let's select the matrix. And why don't we grab it and pull it right after total orders. So as you can see, high ticket orders populated on the bikes row. That's the only product category that's generating sales for products priced over $714, which makes sense. So we see overall about 11,312 orders were categorized as high ticket out of 25,164 overall. But the fact that we had to hard code that number is unsettling to me, and it's not scalable because it won't change as our product list evolves or if we need to refresh data in the future. So it's kind of sloppy analytics, and I don't like it. So let's go back to that measure. And what we're going to do here is use our new friend filter to accommodate this more complex filtering rule. So let's go ahead and clear out the filter argument of our calculate. And just like we added all, we're going to add a filter here. And this is where we're going to define that product price greater than overall average price filter. And here we can reference that measure since filter can handle some of these more complex expressions. So the table that we want to filter is our product lookup table, AW product lookup, because that's the table that contains the product prices that we're testing. And now the filter expression is that the product lookup product price is greater than that measure that we use to calculate overall average price. So kind of a lot going on here. Looking at the filter statement on its own, it's saying, all right, look at the entire AW product lookup table, that list of all our product keys and all those attributes about those products. Go row by row, check the product price, and compare it against our overall average price measure, which we know is $714.44 based on the data we currently have. If the price is greater than $714, we're going to keep the row from product lookup. If it's less than or equal to that average price, we're going to chop that row right out of the table. And then we repeat the process row by row by row until it's gone through the entire product lookup table and hacked it down to a smaller table containing only the products that meet this expression that we just wrote. And then that table as a whole gets passed to the calculate function so that the total orders measure can evaluate against it. So a lot going on there, but you see how this can start to enable some really advanced, really complex stuff. So it looks like we just need to add one more closing parenthesis, and then we should be good to go. So what we're going to watch is this high ticket orders number. And if we've done our jobs, when we hit enter, this shouldn't change at all. So drum roll, please. Enter. There we go. So it refreshed, gave us the correct number that we got when we hard coded the number in there into our basic calculate. But when we replaced that hard coded number with the full filter function, we continue to get the correct number. So that's great news. Now, obviously, that's just one example of how filter and calculate can be combined, but hopefully a good example of how these functions can work together to do some really sophisticated things. So that's your crash course on filter. Next up, we've got iterator functions and SumX.